Looks like we've got our online people turned on. We're on page 365. Exercise 6.4. Someone just asked before class if May 10th is the last class, and the answer is yes. It's on Friday, and you will come in here and take an exam on Friday. So maybe you're wondering, so will you get to correct your exam? And the answer is yes. On Friday, I'll take your test home and grade them, and I'll post your grades on Canvas. And if you want a chance to correct your test, I'll be here Monday morning. You go, but the semester's ended. I know. But I'll give you a chance to correct your test on Monday at 8 o'clock in the morning. Regular class time. Will that work? You won't be here? Well, then you'll just take for your last exam whatever you got on Friday. I don't know any other way to do it. So, does that work for everybody? Actually, if I post your exam score on Canvas and you see what your average is, then you can decide if you want to come in on Monday at 8 o'clock. But I'll be here Monday. That would be 10, 11, 12, Monday the 13th to let you take your test and correct it. Okay, page 365, exercise 6.4. Factor each expression. So number 2 says x squared plus 7x plus 10. And when it says factor, that's what they want me to do. They want me to find the two numbers that you multiplied to get that answer. Do any of you remember how to do that multiplication? I take x plus 2 times x, and I get x squared plus 2x. I take x plus 2 times 5, and I get 5x plus 10. And then I put the 2x and the 5x together, and I get x squared plus 7x plus 10. So I know that this times this equals this number here, and that's called factoring. What it amounts to is I'm just finding, they give me the answer to a multiplication question, and then I find what I multiplied to get that answer. You go, well, I see the answer there, and I see why that's the answer, but what I want, were some of you taught to FOIL it? So let's FOIL it. The first times the first, there's x squared. Outside, 5x. Inside, 2x. Add them, that's 7x. Everybody agree? And then the last times the last, that's 10. So, do you understand that I have the correct answer here in terms of factoring? In other words, I have the two binomials that they multiplied together to get this answer. But when they give you the answer, you need to have a process or a mechanism for finding those two binomials. Well, I don't know if this helps or not, but see this middle term? We get this middle term by adding two things. And this last term, let's change to blue here. We get this last term by multiplying those same two things. So, what two things could I add to get 7? How many ways could I get 7? 6 plus 1, 5 plus 2, 4 plus 3. You follow what's going on? Is that all of them? Looks like it. Now, which two things multiplied would equal 10? 6 times 1 is 6, 5 times 2 is 10, 4 times 3 is 12. Aha! There it is right there. Do you see it? So, I put my parentheses out here. And to get the first term, I had x times x. And to get the last term, I have 5 times 2. And then, since this was plus and this was plus, I go plus and plus. Everybody follow the process? This is kind of, this little blue thing I'm doing is built on the concept of understanding FOIL. Were all of you taught FOIL? So it's really, another way to look at it is you can make a whole bunch of parentheses for binomials and put all the possible numbers in there and then see which one, when you multiply the two binomials, gives you that answer. You don't like that either. Well, let's do another one. Number 4. What two numbers... Now, I should erase that answer because that's making it too easy to see it there. What two numbers multiplied would give me negative 10? Negative 1 and 10, 1 and negative 10, 5 and negative 2, 2 and negative 5. Agreed? Now, which one of these added would give me negative 3 in the middle? Negative 1 plus 10 is 9. 1 plus negative 10 is negative 9. 5 plus negative 2 is 3. 2 plus negative 5, there it is right there. That's my magic combination. You follow it? So I go up here and I put x plus 2 and x minus 5. Does everybody see what's going on? You can start with the addition possibilities and then look to see which two things you're adding multiplied will give you the last term, or you can start with the last term and look at all the possibilities and then say which ones added will give you the middle term, the middle coefficient. You understand what we're doing? It's like we're going on a fishing expedition. It's like hunt and find. Look at all the possibilities and then try them till you find one that works. Well, some of you don't look like you're very enthused about this Easter egg hunt for the correct answer. So guess what? I can't believe I'm telling you about this, but because of the age you live in and because of all the technological advances out there, if anybody has a tablet with them or a laptop, if you Google factoring trinomial calculator. This is disgusting, isn't it? If you don't like hunting around to find this stuff, if you just go factoring trinomial calculator, it will let you plug in the numbers. Like they'll say, what's the, see, this is like ax squared plus bx plus c, and they'll say, what's a, and you'll say 1, and they'll say, what's b, and you'll say -3, and they'll say, what's c, and you'll say -10, and you put and then hit the calculate button, and it will show you this right here. That's just not fair. Is anyone doing one of them yet that way? Did it work okay? I mean, it's like, that's just not fair. But see, it's kind of like if I was saying, you know you can drive a car to work, but today I'm going to teach you how to saddle up a horse and ride him to class. And it's just like, if it's out there, you ought to know about it. But you see, I just enjoy looking at all these possibilities. I enjoy the hunt, looking for the answer. But apparently a whole bunch of people don't, because somebody wrote a program that does all the hunting for you. I mean, can you just see this program at work? It's just going ding. It just tries them all and then pops out the right one and sticks it right there on the screen faster than you can even finish hitting the button. So, since it's there and you know about it, I'm going to say it's okay to use it. The only thing I'm concerned about is if you ever had to go someplace where you had to take a math test and they told you you couldn't use your phone or your laptop or your tablet, would you be able to do this? List all the possibilities and then try them to see which one works? In other words, could you do this process that we've done on problem 2 and 4? Problem 12. Now, see with problem 12, well, there it is. I've got the answer in there. Let's erase it again so you can't see it. And using that FOIL principle, I'm going to have, the only way to get 3x squared is 3x times x. And the only way to get 3 is 1 times 3 or 3 times 1. You follow me? So I say, okay, let's put 3x plus 1 times x plus 3. Then let's do the other one, 3x plus 3 times x plus 1. And then let's see which one gives us this answer. And if you FOIL it, outside, inside, and add 9 and 1, sure enough. So this is the one we keep, and we line this one out. We don't want that one. We keep this other one here. So then we come up here and go 3x plus 1 times x plus 3. And then if you want to check it, multiply it out to see if it works. So this technique kind of builds on, you've had a lot of experience taking the factors and FOILing them, using that FOIL method to multiply them. And if you didn't learn the FOIL method, then you can say, okay, once I have my answer, I can take this times the first term, that's 3x squared plus x. Then I take this whole thing times the second term, and that's plus 9x plus 3 and put those two together, and I get 3x squared plus 10x plus 3. And that was what we started with. So what about solving quadratic equations? Now, when it says solve it, okay, see all of these up here at the top, 1 through 14, it was just factor them. And they just want you to take the answer and find the two factors. Solving means they take the equation and make it equal 0. And you always have to make it equal 0 so you can do this factoring thing. And x plus 2, x squared plus 5x plus 6 factors into x plus 2 times x plus 3. You go, how do you know that? Well, take your factoring trinomial calculator and put in 1 and 5 and 6, and what do you get? X plus 2 times x plus 3. Now, watch this. Here's the key to this thing. If I multiply two things and get 0 for an answer, what does one of them have to be? If something times something equals 0, then one of those somethings has to equal 0. So either x plus 2 has to equal 0 or x plus 3 has to equal 0. So if x plus 3 is 0, then that would mean x would equal negative 3, right? If x plus 2 was 0, x would equal negative 2. Everybody follow that? So now watch how this works. Let's go here and work it. So we say, I have two solutions here. Yeah, I do. I'm going to put negative 2 in place of x. So I'm going to go x squared plus 5 times x plus 6 equals 0. And I'm going to put, the first thing I'm going to put here is negative 2. And what do I get? What's negative 2 squared?
4.
4. What's positive 5 times negative 2?
Negative 10.
Minus 10 and plus 6. Does that equal 0? Does 4 plus 6 minus 10 equal 0?
Yep.
So now let's use negative, what was the other answer we got? Negative 3. Let's put negative 3 in there. Oh, let's just write it over again. The number squared plus 5 times the number plus 6 equals 0. And this time we're putting in negative 3. What's negative 3 squared?
9.
9. What's positive 5 times negative 3?
Minus 15.
Minus 15 plus 6. Does that equal 0?
Yep.
6 and 9 is 15, minus 15 is 0. So do you understand what's happened? When I have this, one of these quadratic expressions, and it says it equals 0, and it tells me to solve it, then the solution is to factor it and then set each of the factors equal to 0 and then find the solutions. Or another way to look at it is, what would turn, do I have another color here? Let's try green. What would turn this, what would x have to be to make that a 0? To make that green circle a 0, what would x have to be?
-2.
-2. See that? What would x have to be to make that green circle a 0?
-3.
Everybody follow that? There's a couple of ways to look at it. You can rewrite it as x plus 2 equals 0, and then subtract 2 from both sides. X plus 3 equals 0, and then subtract 3 from both sides. See what's going on? There's a couple of ways to get there. You just have to find a way that works for you. And you can use, what did I just tell you about? Factoring trinomial calculator. You can use that factoring trinomial thing so you don't have to do all that fishing, trying all the possibilities to see which one works. Even though I happen to think that's a lot of fun. But I get the impression from talking to my wife about this stuff that I work these puzzles called sudokus, where you put in a whole bunch of number possibilities and only one of them works. And I just think it's so cool to sit and work those all day long. And she goes, I have no idea. I've tried those, Tom. I don't know why you enjoy them. And I'm saying, I don't know why you enjoy crossword puzzles, where you have to find words to put in there to fill in these little boxes. She goes, it's not the same thing. I said, no, it isn't. Crossword puzzles are just stupid, but sudokus are so cool. And then I find there are two kinds of people in the world: those who like sudokus and those who like crossword puzzles. And my wife tells me that you live in the world of crossword puzzle workers. Yes?
Sudoku or sumoku?
Sumoku. Sudokus are too easy.
Oh. Thank you for that clarification.
Yes. You got to go find sumokus to have really fun with it. Sudokus, it's like bore me to tears. But sumokus, wow. That'll give you something to work on. And then she says, and so I'm thinking, okay, if you people come from the crossword puzzle side of the world, then I think it's only fair that I should spare you the grief when you're working an exercise like this and say, and you can say, I know how to do this, but to do it all day long wears me out. So just use factoring trinomial calculator and it'll take all these things. The one thing you have to always do, if you haven't figured it out yet, is you always have to rewrite the problem to make it equal to 0. Like for number, let's pick one of yours, number 33, where it says, let's just scroll over here and work one of yours. Number 33, let's change it to black. We'll work one of your problems. 33 says x squared minus 8x equals 20. See, I can't work that one. I need to have it say x squared minus 8x. I subtract 20 from both sides because I want it to equal 0. Minus 20 equals 0. Now I can factor. And see, I just look at this and I'm going, well, it's going to be x and x. And then how am I going to multiply and get 20 and add and get 8 when this is negative and this is negative? So that means one's negative and one's positive. Oh, that's easy. 10 and 2. So it's minus 10 and plus 2. And negative 10 outside 2x, inside negative 10x gives me negative 8x. You understand? I just love working these things. But those of you who say, I just don't see how you jump right in there and find it that fast. Then don't get frustrated, don't get mad, don't burn your book. Just go to factoring trinomial calculator and it'll pop it up faster than I can do it in my head. And then, see, now once I have this, so once I have this, once I've got the two factors, now I'm supposed to solve it. So I go x minus 10 equals 0, or x plus 2 equals 0, which this would be add 10, add 10. This would be x equals 10, or minus 2, x equals negative 2. Or the cute way to write it is the solution is 10 and negative 2. And probably the answer key would say negative 2 and 10, just to put them in order the way they appear in real life in the numeral system. So do you see what you can do? You can use that factoring trinomial thing to get your two factors before you find your answers. Because once you get this far, you don't need a calculator doing that for you. And again, it's the same thing here. What would zero this out? 10. What would zero this out? Negative 2. And those are your two factors, negative 2 and 10. You see that? So there's more than one way to look at it to get there. But probably most of you are going to want to use factoring trinomial calculator. I know there's some other stuff out there you could use to find the answers, but the problem with those is that they just spit out the answer and they don't do the factoring for you. And I think that you're not going to really be hindered mathematically for your future performance on tests if you use the factoring thing, because that's the real big mountain to climb. Is once you've got the factoring done, finding a solution is not complicated. So just go ahead and do that, because I'm sure somebody's thinking, if there's a program that'll do that, then there must be a program that will do the other things on this page too. And yes, there are, but if you're not careful, you say, okay, I know how to punch in the numbers and get an answer, but I don't know what happened. I don't know how I got the answer. So I think it's okay to use tools to help you do your trial and error work, to avoid that, because that is frustrating. That does wear people out. But when it comes to solving them, just go ahead and use that factoring tool and then go ahead and solve them. So are there any here that number 18? They've already factored it. So they've already factored x plus 5 and x minus 6 equals 0. So either x plus 5 is 0 or x minus 6 is 0. So the answer is what? Negative 5 and 6. Negative 5 and 6. Everybody follow what's going on? And probably green doesn't show up very well. Negative 5 and 6. Negative 5, comma 6. I think someone told me one time online. Number 20 is 3 of them. Okay, if I have 3 things multiplied to get 0, then is it obvious I'm going to have 3 answers? Either this could be 0, or this could be 0, or this could be 0. If this is 0, then x is negative 1. If this is 0, then x is negative 2. If this is 0, then x is 3. Do you follow that? If I have 3 parentheses, I'm going to have 3 possible solutions. You go, well, yeah, but if you put, see, watch, what happens? Somebody says, now that I've got my 3 solutions, if you put negative 1 in here, and here, and here, you get 0 times 1 times negative 4. Yeah? You go, does that equal 0? You say, what's 1 times negative 4 is negative 4. Right. And what's negative 4 times 0? So when you put each of those in, you're going to end up getting, say, same with negative 2. You put negative 2 in there, because see, negative 2 zeroes out the middle one, so no matter what the other two end up being, you end up with 0 for an answer when you multiply those three things. It seems like what I've encountered with students is they sometimes were taught how to do this stuff without thinking about what's going on. Because it's like, how can you have more than one answer? Well, plug them in and see. But if you're multiplying three things and any one of those three could be 0, then you're going to have 3 different answers, 3 different solutions to the problem. Why do I have number 22 up here? Because you can get fractions. If this times this is 0, then 3x plus 5 equals 0, or 4x plus 7 equals 0. If we change back to black here and go minus 5, whoops, that didn't work. Doesn't like it. Minus 5, still doesn't like it. What's the deal here? Come on, work with me. Okay. See if it works this time. Minus 5, minus 5. So I get 3x equals negative 5. Then I divide by 3, and I get x equals negative 5/3, which was one of my answers. So sometimes when the two binomials you're multiplying to get 0, if they're a little complicated, then you say, then I'm going to get fractions for answers, and that's going to be okay. Just work them out, and you'll be there. So what's the rest of them? Oh, I suppose we ought to work number 23. Now, if you were going to work 23, number 23, if you were going to work number 23, x squared minus 16 is 0. If you're going to use, what did I call that? Factoring trinomial calculator. They're going to ask you, see, that's x squared plus 0 times x minus 16. So this is 1, this is 0, and this is negative 16 for A, B, and C. You follow that? You have to know how to do that to put the numbers in. And then you put the numbers in, and it'll tell you. But watch this. If I add 16 to both sides, if x squared equals 16, what number squared equals 16? I can either have a 4 or what else? Does a negative 4 squared also equal 16? So I have two answers, 4 and negative 4. So it seems to me like for some of these things, it's easier to do this than go to all the trouble of rearranging this thing, putting 0 in the middle and then putting the 3 numbers in the. In other words, you could go ahead and use factoring trinomial calculator to work that problem, but you have to know that there's a 0 for B, and then it's like, that's more work than just doing this. You say, yeah, it is if you recognize that this is a perfect square. So that if you notice that the number that's standing over there by itself is a perfect square, then you're going to be able to work it out. Like number 24, Yeah. See, 3x squared minus 27 is 0. Well, it happens that I can divide by 3, and I end up with x squared minus 9 is 0, which means x squared equals 9. What number squared equal 9? 3 and negative 3. Everybody follow that? So sometimes you can just get there real fast and you say, what if I wanted to use factoring trinomial calculator to work that problem? Then I would have to go 3x squared. Didn't like me doing that, did it? 3x squared minus 0 times x minus 27 equals 0, and then a, come on, a would be 3, b would be 0, and c would be negative 27. Be sure and put the negatives in there. Don't forget the sign in front goes with it. You say, well, that's a negative 0. Well, is a negative 0 and a positive 0 the same thing? So if you want to, put a negative 0 in there. So I hope I didn't mess you up by introducing you to a internet calculator process that saves you doing all that trial and error stuff. Number 26, same kind of thing. I subtract 1 from both sides. I get 4x squared is 64. Divide by 4. X squared is 16. That would be 4 and negative 4. Would be the two numbers that I could square to get 16. And what would that be? If I wanted to use the internet calculator for it, that would be 4x squared minus 64, which would be 4x squared equals 0, which would be 4x squared minus 0 times x minus 64 equals 0. Then, well, this thing doesn't want to work with me today. What you'd like to know? A would be 4, B would be 0, and C would be negative 64. Plug in the numbers in and hit calculate, and it'll pop up 4 and negative 4 as your answers. So what's number 28? Well, it's 3 things again. So I'm going to end up with 3 answers. X is 0. X is negative 7. Or X is 3 halves. Because if you put 3 halves in place of X, 3 halves times 2 is 3. 3 minus 3 is 0. Well, I think we've done enough of those. We need to move on to the quadratic formula. If you decide to use a quadratic equation calculator, because there's one for that, quadratic formula calculator, I would prefer you use this one, the quadratic equation calculator that shows your work from mathportal.org. So here's the quadratic formula right here in red. Where is that back in your book here?
What?
Page 360. There's the quadratic formula. And I'm supposed to solve these problems using the quadratic formula. So for problem 39, A is 2, B is 3, and C is -5. Okay, tell me what goes in the first space here. 2, 3, or -5?
3.
Everybody see that it's 3? Because it's B. Negative B plus or minus the square root of what goes here?
3.
2, 3, or -5? 3 again. Why? Because that's the formula. -4 times A. So what goes here after the -4? 2, 3, or -5?
2.
2. C. So what goes here? 2, 3, or -5? -5. All divided by 2 times A. So what goes here? 2, 3, or -5? 2. Do you understand? You don't just take the numbers 2, 3, and -5 and stick them in order in the empty spaces. It's B minus B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. And yes, there's a quadratic formula calculator. But the quadratic formula calculator requires you to put in the A, the B, and the C. Now let's go ahead and work this one out just for fun. That would be -3 plus or minus, what's 3 squared? 9. The square root of 9 minus, what's 4 times 2
8.
times 5?
40.
So is it minus or plus 40? A negative times a positive times a negative would be plus 40. All divided by 4. So what does that equal? -3 plus or minus 9 and 4 is the square root of 49. Does that sound like a magic number to anybody? Divided by 4. So what we have are two answers. -3 plus 7 over 4 or -3 minus 7 over 4. -3 plus 7 would be -10. No, that would be 4 over 4. That would be 1. And -10 over 4, that would be -5/2. And those are your two solutions. And what happens is, if you use quadratic formula calculator, and it'll tell you to plug in A, B, and C, and then it'll do the calculation and it'll spit out those two answers. If you're doing it manually, make sure you follow the order. And I think the best way to do it is you take the quadratic formula, then you copy the quadratic formula with empty spaces, and then you fill in the empty spaces with A, B, and C. Let's go to number 40. Here's A, here's B, and I always circle them so I don't forget the sign, and here's C. So X equals what number goes here? 3, -7, or 2? You have to have that formula laying in front of you to look at it. It's B, so it's -7. What goes here? B again, -7. What goes here? A. 3 times what goes here? C, 2 over 2 times what? A, 3. So now we have the opposite of negative 7 is 7 plus or minus, what would that be? The square root of 49 minus 24, all divided by 6, which equals 7 plus or minus 49 minus 24 is the square root of 25 over 6. So that's 7 plus 5 over 6, or 7 minus 5 over 6. And that would give me 12 over 6, which would be 2. And this would give me 2 over 6, which would be 1/3. And those would be the two solutions. And again, for number 48, you have to make it equal 0. So I go 7x squared minus 12x plus 5, add 5 to both sides. To make it equal 0, and then A is 7, B is negative 12, and C is positive 5. And you fill in the spaces and do the work. Skip problem 55. That's not worth messing with. And 56 is use the Pythagorean theorem. Does everyone know what the Pythagorean theorem says? It says a squared, let's go back to black here again if it'll let me. A squared plus B squared equals C squared. Here's A, here's B, here's C in a right triangle. Has to be a right triangle. 3 is 9. 3 squared is 9. 5 squared is 25. 4 squared is 16. And 9 plus 16 adds up to 25. And when Pythagoras discovered that, oh, the world of Pythagoras' day went crazy. And they said, we now have a theorem named after you, Pythagoras. So now we use it all the time. So let's do number 56, using this Pythagorean theorem. The sides of a right triangle, so they've already told me it's a right triangle, are consecutive even integers. Okay, even, if it said consecutive integers, it could be like 1, 2, 3, 4, 5, 6, you follow me? 7, 8, 9, but it says even. So here again, I'm back to my try all the possibilities. 2, 4, 6, 4, 6, 8, 6, 8, 10, and just keep going till I find the answer. You go, that's way too much work. No, it isn't. What's 2 squared?
4.
4. Plus 4 squared, 16. Does that equal 6 squared, 36? Nope. So 4 squared, 16. Plus 6 squared, 36. Does that equal 64? Nope. 6 squared, 36. Plus 8 squared, 64. Does that equal 100? Yes. So I just found it. It's a 6, 8, 10. Everybody follow what I'm doing? If you want to do it with algebra, you could call this side x, and then this side would be 2 more than x, even numbers, and this one would be 4 more than x. Then you would have x squared, square of that side, plus x plus 2 squared, plus x plus equals x plus 4 squared. And when you work all that out, all of this becomes all of this becomes all of this, and you end up with, what would that be? Minus x squared minus x squared minus 8x minus 8x minus 16 minus 16, and that would be x squared minus 4x minus 12 equals 0. And then if you're using your factor thing, you go, this is 1, a is 1, b is negative 4, and c is negative 12. But see, I'm thinking, just draw your factors. Here's x and x, and here's 6 and 2, and it's negative 6 and positive 2. So the answer is either negative 2 or 6. I can't have the side of a triangle being negative 2, so it has to be 6. If that's 6, then that's 8, and that's 10. Everybody follow what's going on? Now, which would you rather do? Solve it with algebra, or use the trial and error method till you find it? Or, I think those are your only possibilities. Number 58. The hypotenuse of the right triangle is 16 inches longer than the shortest side. So let's change the red here. So that's here's the shortest side, and this one's the hypotenuse is 16 inches longer. And what else does it say? And 2 inches longer than the other side. So if this is 2 inches longer than this one, that makes this one x plus 14. Everybody follow where I'm getting my numbers? This one's x, this one's 16 longer, and this one is x plus 16 minus 2, which would give me x plus 14 for this one here. Then I use the Pythagorean theorem, x squared plus x plus 14 squared equals x plus 16 squared. And I multiply those and work them all out and come up with the answer is either 10 or negative 6. And I can't have a negative 6, so it has to be 10. So 10, and then this, if this is 10, 16 more would be 26, and this is 14 more would be 24. 10 and 24 and 26. Number 61 to 64. It says use this formula right here. They're just giving you a formula and saying plug in the numbers. And 62 says h is 28, v sub o is 4, and we don't know what t is. So we come over here and go h, remember this is h, equals 5t squared plus v sub o times t. And h is 28, and v sub o is 4. So now we have 28 equals 5t squared plus 4t. We want it to equal 0, so we subtract 28 from both sides. Let's put it out here. So now we have 0 equals 5t squared plus 4t minus 28. Probably you could use the quadratic formula, or you could just use your, what do we call that thing over there? Your factoring trinomial calculator, and plug in a is 5, b is 4, and c is negative 28, and it'll factor it for you. Or you could use that thing that I told you about, quadratic formula calculator or quadratic equation calculator. and find your answers. But you have to be able to, the computer is not going to set it up for you. You have to set the problem up, and then it'll find the answer for you. Number 64 says, how long will it take a package thrown downward from a plane with an initial velocity of 10? So V is 10 from a height of 175. So I put 175 equals 5t squared plus 10t. And then do the same thing again. Oh, this time I saw I could divide them all by 5 and come up with t squared plus 2t minus 35. And that would be t plus 7 times t minus 5. So my answers are negative 7 and 5. So what time? Negative doesn't make sense for time, so I put in 5 is my answer for time. So sometimes you can just see them and you don't have to do all that computation or plug in all those numbers. Number 66. Stop when you get to 69. The cost of serving X customers, this is the cost, is x squared plus 10x plus 100. If $1,300 was spent serving customers, so the cost is $1,300. So that equals this number here. Then subtract 13 minus 1,300 minus 1,300, and you get 0 equals x squared plus 10x minus 1,200. And see, you could plug in 1 is A, 10 is B, and negative 1,200 is C. But when I look at 1,200 and I see 10 and that's negative, I'm going, oh, that's x plus 40 times x minus 30. If you don't see that, then just use your factoring on the computer to plug in A, B, and C, and it'll pop up there and it'll show you those are the two factors. So it's either negative 40 or 30, and it can't be a negative number, so it has to be, what are we looking at, 66? How many customers did we have? 30 customers. Oh, it looks like we're out of time. So we'll just say, stop when you get to 69. You know, I'm thinking I better work 69 for you. Do you want to do it today or tomorrow? I mean Friday. Friday? Okay. You've had enough of this. We'll save it and work it on Friday. Before class starts, of course. If you have any questions, stick around. I'll be glad to answer them for you from past assignments.